Welcome to Study Loop.
Hello everyone, this is a solution to problem 50, chapter 24 of College Physics. Here we are asked to find out a few things about radio waves, namely waves of the AM and FM bands of radio signals. So just a quick Google search reveals that the frequency range for AM radio signals is between 540 times 10 to the 3 hertz or 540 kilohertz and 1600 times 10 to the 3 hertz or 1600 kilohertz. So the interesting thing about AM waves is that they transfer information or sound information through electromagnetic radiation in a form where the amplitude of the wave is modulated. And that's what AM stands for. It's amplitude modulation. So what happens is that there is a part of the equipment that produces the signal that creates a wave with a constant frequency and a constant wavelength. But then that signal becomes attenuated by another part of the equipment that changes the amplitude. And so the resulting wave that comes out of such an equipment is going to be of a given frequency and a given wavelength, but its amplitude is going to change, as you can see over here. So basically there is a carrier wave that's inside, which is of the same frequency, and then it has an envelope which changes the amplitude of the signal. Now, the nice thing about these frequency ranges and these wavelength ranges is that they are they are such that they get reflected from the ionosphere, so from the upper atmosphere. Why that's good is that this effectively allows you to project and transmit your signal very far away, and effectively, if you make the wavelength big enough, all the way around the globe. So if you have the surface of the Earth here, for example, there is some patch of land, and then there's a radio signal that emits AM waves or AM radio signals, then the wave comes out and it reaches the upper parts of the atmosphere, gets reflected, and then moves back down to Earth. But it doesn't only get reflected, it also gets refracted. And in such a case, the ionosphere can act kind of as a waveguide. So you would have part of this wave reflecting back, but part of it would like kind of move around the atmosphere and it would be guided around the entire Earth. So that's one of the great uses and benefits of AM waves, is that you can transmit signals to very far away. However, the shortcoming of AM waves is that they are subject to interference. And that's because they are only confined to a single frequency. So anything that projects or anything that creates electromagnetic waves of the same frequency is going to cause interference, and that's going to mess up your signal. And that's why you often hear static if you're, for example, trying to listen to an AM transmission, but you are in the vicinity of, for example, bad weather, then you could have reflections from the other parts of the atmosphere or components of the weather that transmit or create other waves that interfere with your signal. So that's all we have to say about AM waves, or amplitude modulation or amplitude modulated radio signals. How about FM waves? So FM waves, they have a frequency of about 88 times 10 to the 6 hertz and 108 times 10 to the 6 hertz. So 88 megahertz or 108 megahertz. And these guys have a fairly steady amplitude, but they have different frequencies. So here, as you can see, this is what I tried to represent with this wave, is the envelope, the red overarching thing of the or curve of the signal is fairly constant. It's a steady amplitude, but the frequency, as you can see, varies. So that's why I have this jumbled curve that gets stretched out and compressed and stretched out and so on and so forth. Now, these frequencies actually do not get reflected from the ionosphere. So if you have the same kind of setup as you had over here for the AM waves, these are much shorter wavelength. And so what happens is that these guys just get transmitted through the atmosphere. And so they don't actually get reflected back, and you can't transmit FM waves to very far away. So the only thing you can do is in your local area, as far as you can see on the horizon, you can transmit waves. That's why FM waves only work in a given region, and that's why you only get good signals there.